Hello students, how are you? I hope all of you are good. In my previous video, I completed up to the question number 11 in the exercise 11.2. So today in this video, I am going to continue from the question number 12. And the question is, find the shortest distance between the given two lines, where vector equations of the lines are given here. To identify the shortest distance between these two lines, first we should know whether the given lines are skew lines, whether the given lines are skew lines or parallel lines or parallel lines. To identify that, we need to know whether the direction vector of both the lines are same or different. See here the direction vector of the first line. So compare this line with the standard form, that is r vector is equals to a1 vector plus lambda times of b1 vector. So b1 vector is the direction vector of the first line, and the second line r vector is equals to a2 vector plus mu times of b2 vector, where b2 vector is the direction vector of the second line. So by comparing the first line with this form, b1 vector is, by comparing the first line with the standard form, b1 vector is I minus j plus k, I minus j plus k. And by comparing the second line with the standard form, r vector is equals to a2 vector plus mu times of b2 vector. So b2 vector is 2i plus j plus 2k. So observe here, b1 vector is different from b2 vector. It means direction vector of both the lines are different, hence the given lines are skew lines. And to know the shortest distance between these two lines, we know the formula, that is what? Distance d is equals to modulus of b1 vector cross b2 vector dot a2 vector minus a1 vector divided by magnitude of b1 vector cross b2 vector. So to identify the shortest distance, we need b1 vector cross b2 vector and a2 vector minus a1 vector. So we already have the b1 vector and b2 vector. We need a1 and a2 vectors. For that, compare these two given lines with again this standard form of lines. In place of a1 vector, we have I plus 2j plus k. Therefore, a1 vector is equals to I plus 2j plus k. And a2 vector is equals to, compare the second line with the second form, that is what? R vector is equals to a2 vector plus mu times of b2 vector. So in place of a2 vector, we have 2i minus j minus k, 2i minus j minus k. So we got the required vectors a1 vector, a2 vector, b1 vector and b2 vector. Now we need to identify a2 vector minus a1 vector. So a2 vector minus a1 vector is equal to, see here, 2i minus I minus j minus into plus minus 2j. So minus j minus 2j is minus 3j. Similarly, minus k minus into plus minus k minus k minus k is minus 2k. So we got a2 vector minus a1 vector. And also we need what? b1 vector cross b2 vector. Now what? b1 vector cross b2 vector is equals to the cross product of two vectors obtained by using the determinant method. Already we have been studied in the vector algebra chapter. So therefore b1 vector cross b2 vector is determinant of where first row is unit vectors I, j and k, and the second row is coefficient of I, j, k in b1 vector, that is what? 1 minus 1 1, 1 minus 1 1, and third row is coefficient of I, j, k in b2 vector, that is 2 1 2, 2 1 2. So as you already known that method of solving the determinants. So in the first column, this what? Plus minus plus, which is equals to I into, deleting this first row first column, minus 1 into 2 minus 2 minus 1 into 1 1, then minus j into, deleting first row second column, 1 into 2 2 minus 2 into 1 2, and then plus k into, deleting first row third column, 1 into 1 1 minus 2 into minus 1 minus 2 minus into minus plus 2. Therefore b1 vector cross b2 vector is equals to I cap minus 2 minus 1 is minus 3 minus j cap 2 minus 2 is 0 plus k cap 1 plus 2 is 3. So finally required b1 vector cross b2 vector is equals to minus 3i minus 0j plus 3k. So we got a2 vector minus a1 vector and b1 vector cross b2 vector. Now we need the magnitude of b1 vector cross b2 vector. Therefore, magnitude of b1 vector cross b2 vector is equals to square of the I coefficient minus 3 square is 9 plus 0 square 0 plus 3 square is 9. So which is equals to root 18, and root 18 can be done as root 9 into 2, and root 9 is equals to 3 root 2 as it is. Therefore, the magnitude of b1 vector plus b2 vector is 3 root 2. Now substitute the obtained value a2 vector minus a1 vector, b1 vector plus b2 vector, and its magnitude in the distance formula. So distance is equals to b1 vector plus b2 vector is minus 3i minus 0j plus 3k minus 3i minus 0j plus 3k dot a2 vector minus a1 vector is I minus 3j minus 2k, I minus 3j minus 2k divide by magnitude of b1 vector plus b2 vector is 3 root 2. Now which is equals to dot product of two vectors obtained by multiplying the coefficients of I with I, j with j and k with k. Therefore minus 3 into 1, minus 3 into 1 is minus 3, 0 into minus 3 is 0, and then 3 into minus 2 is minus 6 divided by 3 root 2. So therefore finally we got d is equals to see here, d is equals to minus 3 minus 6 modulus of minus 9 divided by 3 root 2. Here we can cancel 3 ones, 3 threes. So d equal to modulus of minus 3 divided by root 2, and distance is always positive, so modulus of minus 3 is plus 3, so 3 divided by root 2, or you can rationalize here. For rationalizing, divide and multiplied by root 2. Therefore d equals to 3 into root 2, root 2 divided by root 2 into root 2 is 2, so hence the required distance is 3 root 2 divided by 2 units. I hope all of you understood. And this question is most important question, many times asked in your annual examination for 3 marks. I hope all of you understood this question. And the next question is, find the shortest distance between the lines. In this questions also we need to identify the shortest distance between the given two lines. But in this question he has given the Cartesian equations of the line. So to identify the shortest distance between these two lines, first we need to know whether the given lines are skew lines or parallel lines. So for that, we should know the direction ratios of both the vectors are same or different. If same, they are parallel vectors. If different, they are skew lines. So therefore, for identifying the direction vectors of both the lines, first compare these two given lines with the standard forms of the Cartesian equations of the line, where the Cartesian equation of the first line is of the form x minus x1 divided by a1 equal to y minus y1 divided by b1 equal to z minus z1 divided by c1, and the Cartesian equation of the second line is x minus x2 divided by a2 equal to y minus y2 divided by b2 equal to z minus z1, sorry, z2 divided by c2. Now see here, this first line passes through the point, first line passes through the point x1, y1 and z1, and its corresponding vector is a1 vector, and the direction ratios of the first line is a1 b1 c1, and its respective vector is b1 vector, which is equals to a1i plus b1j plus c1k. Similarly, this second line passes through the point x2, y2 and z2, and its respective vector is a2 vector, and the direction ratios of the second line is a2 b2 c2, and its respective parallel vector b2 vector is a2i plus b2j plus C2k. Now by comparing this first line with the standard form, we got A1 vector and B1 vector. So see here, the value of x1 in this x plus 1 can be written as x minus of minus 1 divided by 7. Therefore, in place of x1, we have minus 1. Therefore, this first line passes through the point minus 1. And similarly, y plus 1 can be written as y minus of minus 1. So, therefore, y1 is also minus 1. And z plus 1 can be written as z minus of minus 1. Therefore, z1 is equals to minus 1. So, in place of z1, we have minus 1. Therefore, z1 value is minus 1. So, the first line passes through the point minus 1, minus 1, minus 1. It means its respective vector a1 vector is equals to minus I, minus j, minus k, minus 1I, minus 1j, minus 1k. And similarly, by comparing the first line with this first standard form of the line, b1 vector is equals to a1i plus b1j plus c1k. Here the value of a1 is 7 and b1 is minus 6 and c1 is 1. Therefore, b1 vector is equals to 7i minus 6j plus 1k. So we got the a1 vector and b1 vector from the first line. To identify the a2 vector and b2 vectors, compare the second line with the standard form of line. So therefore, see here, in place of x2, we have 3. Therefore, the value of x2 is 3. In place of y2, we have 5. Therefore, y2 is 5. And in place of z2, we have 7. Therefore, z2 is 7. Hence, its respective vector a2 vector is 3i plus 5j plus 7k. Therefore, a2 vector is equals to 3i plus 5j plus 7k. And similarly, B2 vector is equals to values of A2, B2, C2 is 1 minus 2, 1. Hence, B2 vector is A2i plus B2j plus C2k. Therefore, B2 vector is 1i minus 2j plus k. So, finally, we got A1 vector, B1 vector and A2 vector, B2 vectors. And also, we know the formula for shortest distance between two lines. That is what? D equal to modulus of b1 vector cross b2 vector dot a2 vector minus a1 vector divided by magnitude of b1 vector cross b2 vector. So first we need to find the value of a2 vector minus a1 vector. Now what? A2 vector minus a1 vector, which is equals to 3i minus, see here a1 vector ಏನಂದ್ರೆ minus I. So minus into minus I plus I. Therefore 3i plus I is 4i. Similarly 5j minus, ಇಲ್ಲಿ ನೋಡ್ರಿ ಏನದ minus j. So minus into minus plus. So plus j. And 5j plus j is 6j. And similarly 7k minus, ಇಲ್ಲಿ ಏನದ ನೋಡ್ರಿ minus k, minus into minus plus k. So therefore 7k plus k is 8k. So finally a2 vector minus a1 vector is 4i plus 6j plus 8k. And then we need what? b1 vector cross b2 vector. So therefore b1 vector cross b2 vector is equals to determinant of first row is the unit vectors I, j, k, and second row is coefficient of I, j, k in b1 vector, that is 7 minus 6 1, 7 minus 6 1, and third row is coefficient of I, j, k in b2 vector 1 minus 2 1, 1 minus 2 1. So therefore b1 vector cross b2 vector is equals to plus minus plus I into deleting the first row first column minus 6 into 1 minus 6 minus minus 2 into 1 minus 2 minus into minus plus 2, and then minus j into deleting first row second column 7 into 1 7 minus 1 into 1 1, and then plus k into deleting first row third column 7 into minus 2 minus 14 minus 1 into minus 6, minus 6, minus into minus plus 6. Therefore, B1 vector cross B2 vector is equals to I into minus 6 plus 2 is equals to minus 4, minus j into 7 minus 1 is 6, plus k into minus 14 plus 6 is minus 8. So therefore, B1 vector cross B2 vector is equals to minus 4i minus 6j plus into minus minus 8k. We got the B1 vector cross B2 vector. Now we need its magnitude. That is what? B1 vector cross B2 vector is equals to magnitude of B1 vector cross B2 vector is equals to square of the I coefficient. Minus 4 square is 16 plus minus 6 square is 36 plus minus 8 square is 64, which is equals to square root of 64 plus 36, 100 plus 16 is 116. So therefore, the magnitude of B1 vector plus B2 vector is root 116. Now substitute these three values, A2 vector minus A1 vector, B1 vector plus B2 vector, and magnitude of the B1 vector plus B2 vector in the formula, that is D is equals to, that is D is equals to, D is equals to modulus of B1 vector cross B2 vector is minus 4i minus 6j minus 8k, minus 4i minus 6j minus 8k dot A2 vector minus A1 vector is 4i plus 6j plus 8k, 4i plus 6j plus 8k divided by magnitude of B1 vector plus B2 vector is root 116. Therefore, D is equals to, see here, minus 4 into 4, minus 16, minus 6 into 6, minus 36, minus 8 into 8, minus 64, divided by root 116. So therefore, the value of D is equals to, therefore the value of D is equals to modulus of minus 64 minus 36 minus 100 minus 100 minus 60 is minus 116. So minus 116 divided by root 116, root 116. Hence, D equal to modulus of minus 116 is 116 divided by root 116. And we know that 116 can be written as root 116 whole square, root 116 whole square, root 116 whole square divided by root 116, and 1 root 116 from denominator and 1 root 116 from numerator get cancelled. Finally we got D is equals to, finally we got D is equals to, see here ಇಲ್ಲಿ ಬರೀತೀನಿ ನೋಡ್ರಿ, D is equals to root 116, and root 116 can be written as square root of, see here, 4 2s are 8, remains 3, 4 9s are 36. Hence the final answer D equals to square root of 4 can be written as 2 into root 29 units. Therefore, required shortest distance between the given lines is 2 root 29. I hope all of you understood. Let's start the next question. And the next question is, find the shortest distance between the lines. So in this question also we need to find the shortest distance between the lines. So for finding the direction vectors, compare this first line with r vector is equals to a1 vector plus lambda times of b1 vector, and second line with r vector is equals to a2 vector plus mu times of b2 vector. So by comparing these two, we got a1 vector is equals to, a1 vector is equals to, see here, in place of a1 we have I plus 2j plus 3k, I plus 2j plus 3k, and b1 vector is equals to I minus 3j plus 2k, b1 vector is equals to I minus 3j plus 2k. Similarly, by comparing the second vector equation with this line, in place of a2 vector, in place of a2 vector, we have 4i plus 5j plus 6k, 4i plus 5j plus 6k. And in place of b2 vector we have 2i plus 3j plus k. Therefore b2 vector is equals to 2i plus 3j plus k. I hope all of you are understanding. And we know the formula to find the shortest distance between these two skew lines. See here, b1 vector is different from b2 vector. Therefore, these two lines are the skew lines. And the formula for finding the shortest distance between two skew lines is d equal to modulus of b1 vector cross b2 vector dot a2 vector minus a1 vector divided by magnitude of b1 vector cross b2 vector. So we need the values of a2 vector minus a1 vector and b1 vector plus b2 vector. So therefore, firstly, a2 vector minus a1 vector, which is equals to a2 vector, see here 4i minus I, which is equals to 3i. Similarly, 5j minus 2j, which is equals to 3j, and 6k minus into plus minus 3k. 6k minus 3k is 3k. So we got a2 vector minus a1 vector, and then we need b1 vector cross b2 vector. Now what? b1 vector cross b2 vector is equals to determinant of first row is the unit vectors I, j, k, and second row is coefficient of I, j, k in b1 vector 1 minus 3 2 1 minus 3 2, and third row is the coefficient of I, j, k in b2 vector 2 3 1 2 3 1. Therefore, b1 vector cross b2 vector is equals to b1 vector cross b2 vector is equals to plus minus plus. So I into deleting first row first column minus 3 into 1 minus 3 minus 3 into 2 is 6, and minus j into deleting first row second column 1 into 1 1 minus 2 into 2 4, and then plus k into deleting first row third column 1 into 3 3 minus 2 into minus 3 is minus 6 minus into minus plus 6. Therefore, b1 vector cross b2 vector is equals to I cap minus 3 minus 6 is minus 9 minus j into 1 minus 4 is minus 3 plus k into 3 plus 6 is 9. So finally, b1 vector cross b2 vector is equals to b1 vector cross b2 vector is equals to minus 9i minus into minus plus 3j plus 9k. And then we need the magnitude of b1 vector cross b2 vector. Now what? Magnitude of b1 vector cross b2 vector. Magnitude of b1 vector cross b2 vector is equals to square root of minus 9 square is 81 plus 3 square is 9 plus 9 square is 81. Magnitude of b1 vector cross b2 vector is equals to square root of 81 plus 9 is 90, 90 plus 81 1 9 plus 8 17, so 171, and which is equals to, see here, root 171 can be written as square root of 19 into 9, and square root of 9 is 3, so 3 root 19 is a magnitude of b1 vector cross b2 vector. Now substitute the values of a2 vector minus a1 vector and b1 vector plus b2 vector and its magnitude in d formula. D equal to modulus of b1 vector plus b2 vector is minus 9i plus 3j plus 9k minus 9i plus 3j plus 9k dot a2 vector minus a1 vector is 3i plus 3j plus 3k, 3i plus 3j plus 3k divided by magnitude of b1 vector plus b2 vector is 3 root 19. Therefore, d equals to minus 9 into 3 minus 27, 3 into 3 9 plus 9 into 3 27 divided by 3 root 19. Now see here, in numerator minus 27 plus 27 get cancelled, and remaining D is equals to D equal to 9 divided by 3 root 19, 9 divided by 3 root 19. So again 3 ones are 3 threes are. So finally distance D is equals to 3 divided by root 19 units. So required distance between the given two lines is 3 by root 19 units. I hope all of you understood.